Today we're going to look at a concept that we've talked about in class before, but now we're going to look in a little more detail, and it's called the law of conservation of mass. We'll get to the definition of the law of conservation of mass, but first I want to describe to you guys two systems that occur whenever you have a chemical reaction. You have what's called an open system, and you have what's called a closed system. An open system is when the matter and the energy are free to completely move about. It's not contained. A closed system is the opposite. That's when matter is going to be contained inside some type of container. So let's go ahead and take a look at the open system and an example. So the example I have with an open system is, imagine that you have some wood. Okay, so let's draw some wood right here. So we're going to be burning a little fire, a campfire, because it's cold. Okay, so just draw a couple pieces of wood, something like that. Okay, so there's our wood. And what we're going to do is we're going to weigh that wood before we burn it. And then we're going to light it on fire. Okay, so now it's on fire. And if you remember, we were talking about this yesterday, that when you burn paper, you start off with this molecule called C6H12O6, lots of sugar inside of paper, inside of wood as well. And what ends up happening is it emits carbon dioxide and water. That matter just goes up into the air. So the end result is we get something that looks like this. At the end of the fire, we get ash. And what has happened is that we have lots of stuff that's going everywhere. We've got smoke. And what smoke is actually, it has gas particles, but also contains little tiny microscopic solids in it as well. So we get smoke, we get carbon dioxide, and we also get water. And these things are free to move up into the air. So these go up into the air. And we're left with this ash, and this ash is probably mostly just carbon is what it is. And if we weigh the ash, so we're going to weigh this ash at the end, and we're going to compare it to the weight of the wood, what's the weight of the ash going to be? The weight of the ash is going to be less. So the ash is going to weigh less, meaning it has less mass. Well, it seems like we've lost mass in this reaction. We started off with a higher mass, we went to a lower mass. But we actually didn't lose the mass. The mass went into the smoke, into the carbon dioxide, and to the water. All those things went into the air. So this is where all the lost mass goes. And I'm going to put lost in quotes because it's not really lost, it's just the mass is going somewhere else. So we have our lost mass, and that goes somewhere else. This is what an open system is. In an open system, matter, so the matter of the carbon dioxide, the water, and the smoke particles, matter is free to move. And also, we can say the same thing about the energy. There was a lot of heat that was released from this. So the energy of the heat is also free to move. Okay, this again is an open system, meaning that there's nothing to contain the smoke, the carbon dioxide, and the water. Let's take a look at a closed system. Closed system is the opposite. Imagine you have a safe. So just draw a square. Okay, so here's my safe. And I'm going to put a stick of dynamite in it. Okay, and we're going to light that dynamite on fire. Okay, dynamite. And now we close the door. Okay, so we have the door is closed. So it's a closed door. And then a few seconds later, boom, Okay, the dynamite explodes inside the safe, and the safe remains intact. Okay, so what ends up happening to that dynamite on the inside? Okay, so we end up with the safe. Again, the safe is still closed. So it's a closed door still. What's happened to the dynamite? It has disintegrated into multiple smaller pieces. Okay, so we just have all this stuff, and eventually it'll settle down on the bottom. We also may have some gases that are produced from this. So we have some solids, we have some gases, but we weigh the safe before, and we weigh the safe afterwards. What's the weight of the safe going to be after the explosion? Remember, the door is closed. What should happen is the safe should weigh the exact same. Nothing has changed because this is a container. The safe is the container. It has contained everything. The door is closed, and nothing has escaped. The gases have not escaped. The solid particles have not escaped. So it has all the same particles on the inside that it started over here. Here it's nice and compacted inside a dynamite stick. Now it's spread out all over the place. So the mass is going to stay the same. So the mass stays the same. So this is a closed system. So with a closed system, matter is going to be contained. All of my carbon and hydrogen, oxygen, nitrogen, whatever was inside the explosive stays inside the safe. It doesn't escape. However, if you were to feel the temperature of the safe, it's probably made of some type of metal material. If you felt the temperature of the safe before, probably room temperature, what would the temperature of this be afterwards, after that giant explosion? It would probably be warm. You'd probably feel the sides of the safe and it feels warm to you. So what does that mean? Well, that means the heat is going actually through the material. It gets transmitted into the metal, and then that heat will then get lost to the air. Do we lose mass? No, the mass stays the same. However, the energy is free to move. So while the mass is contained, just like in this system, where we lost lots of heat and that heat went out into the air, the same thing happens here. Energy is free to move, and the heat is free to move. So in both systems, an open system and a closed system, the energy is free to move. In the open system, the mass or the matter is also free to move, but in a closed system, the mass is going to be contained. So energy and heat, they're able to work themselves through other materials. It's transmitted to all the molecules, and then it's actually makes them move faster on the inside of the safe. That's going to heat them up and make them feel warmer. And then those molecules will then lose that energy to the air on the outside. So the mass stays the same, but the energy is free to move. So let's get to the definition of the law of conservation of mass. We talked about chemical reactions where we can't gain or lose any atoms. It's the same concept right here. So the law of conservation of mass states two things: that mass is neither created, and I think you might be able to finish this, nor destroyed. There's one more point after mass is neither created nor destroyed. The mass, though, however, can be transformed from one substance to another. This is what happens in chemical reactions. Mass can be transformed into, or transformed from one substance to another. meaning that we start off with lots of nitrogen and oxygen compounds. We still will end up with nitrogen and oxygen compounds over here, but they're going to be in a different form. They've been chemically rearranged to make new materials. And if you remember, it's just like the fire. We're starting off with these carbons, hydrogens, and oxygens, and we end up with ash, which is primarily just carbon, and we lose a lot of the oxygen and hydrogen in the form of carbon dioxide and water. That is it for the law of conservation of mass. We'll discuss this another time.